Question number 1. This is your 9 for review on Monday, January 30th, 2018.
29.
29th?
Yeah.
Oh, okay. We have 9 questions here, and the other 9 we'll do after. The first question in our 9 for is a fraction bed mass question. Is a bed mass question featuring mixed fractions. So remember, when you have more than one operation in any expression, you simplify, you have to do bed mass. So multiplication is done first, which means I'm going to keep 1 2/5, which is actually 7/5 first. I'm going to ignore the rest of it. I'm just going to solve this question here. So 1 2/5 is 7/5 times 3/4. So I'm going to do that first. So 7/5, which is 1 2/5, plus 21/20 is what I would get when I multiply letters, because when you multiply fractions, you multiply the numerators, and you multiply the denominators. You do not need to have a common denominator. So now that I'm adding, I require common denominators. In this case, I will choose 20. This will not change, but this one will become 28/20. And when I add those two, I get 49/20 as my answer, or 2 and 9/20. In the second example, second question, we have a bed mass question with integers only. So the first question is brackets. So we have to simplify everything up there. It's actually brackets within brackets. So a negative 10 take away 5 is the same thing as negative 10 take away a positive 5, because that's a positive. So if I like to keep flip change, it's really a negative 10 plus a negative 5, which is negative 15. So I'm still inside the brackets. I simplified that first. Take away the product of negative 3 and negative 2, which is positive 6. So when I keep flip change there again, so keep flip and change, I get negative 21, and then I got to put over negative 22, negative 2, which really means divided by negative 2. Now 21 divided by 2 is 10.5, 10.5. And a negative divided by a negative is a positive. So my answer for the second question is 10.5. Okay, the third question is an algebra question. It has a constant, it has a coefficient, and it has a value. So really, the first thing you really need to realize is if I was to draw this, it'd be negative 4x and it'd be negative 2x. We talked about modeling it like that, equals positive 6. So if I was to draw it, that's what it would look like. And when we see it that way, we realize that our constant is our negative 4. So the first thing I'm going to do is get rid of that constant by adding 4 to both sides. That gets rid of my constant. The important thing, the place that most people make mistakes, is that that negative sign really stays with the coefficient. So it's a negative 2x equals the sum of these, which is positive 10. And because it came down with it, when I want to isolate, I need to divide both sides by negative 2, not 2, and therefore x would equal a negative 5. In the fourth question, we have a graph. So the first thing you need to make is your table of values. So put down x and y. X is 6, y is 4, x is 12, y is 6, x is 18, y is 8, and x is 24, and y is 10. So when I look for my difference here, it's 2. When I look for my difference here, it is 6. Remember, 2 divided by 6 is going to be your coefficient. 2 divided by 6 in lowest terms is 1/3. So that means my coefficient I can either use as a repeating decimal, which means decimal 3 repeating, or the better way to do that is to put it as, oh, I just shouldn't erase that table value. Hang on. Since that is my, I know that's not going to work either. Let's do it over here. I'll borrow from the space above. Because you already know the answer. No. Okay. So we know that 1/3 is my coefficient. So when I put down x and y, I want to say 1/3 of x. So I could do 1/3 of x like this, but very impractical. By now you realize that this is really 1/3 of x. So for a 1/3 coefficient, for this is my coefficient, I really want to express it this way up here. So 1/3 of x. Go in and take your first ordered pair, which is 6 and 4. I'm going to substitute x for 6 and y for 4. 6 here and 4 here, and see if they're equal. Well, 6 divided by 3 is 2. So 2 does not equal 4, but if I add 2 to it, it works. So therefore, your equation is third of x plus 2 equals y, or 0.3 x 0.3 repeating x plus 2 equals y, or you could have put 2/6 x plus 2 equals y. But of all three of those choices, obviously, this is the best one. So that was the hardest question probably in 9 for determining the equation. Just make sure when you have fractional coefficients, you can either show them with a decimal coefficient or as a fraction. Okay. I might just use this for the next one too. So here we have what appears to be a right triangle. And we know two of our side lengths. I know these are sides because the units that are used to express them are meters, not square meters. And here it is given the area of a square attached to the leg of a potential right triangle as being 9 meters squared. So what it's saying is it a right triangle? Well, if I draw my squares onto the sides here, a square with a side length of 4 meters would have 16 meters squared in this area. And since Pythagoras said the area of the two legs equal this would have to be 25 meters squared, and therefore the square root of 25 would be the length of it, and it is that. So then yes, it is a right angle, because it follows Pythagorean theorem. Pythagorean theorem. The next question, 24% of 80. Now, if you were doing this in the real world, oh crap, burgers. Okay, so for the next one, 24% of $80. There are two ways you could do it. You could think of 24% as being 24 hundredths, which in decimal form is 24% of, you can think of it as being multiplication. And you could actually multiply that out and get 19.2. Okay? And that would be $19.20. But the other way you could do it is using mental math. So if I said 25% take away 1% equals 24%, then all I have to do is find out what 25% is. And 25% of 80 is half of half. So half is $40, and half of that would be $20. So 25% would be $20. And for 1%, in grade 7 you learned that for 1% you move your decimal 2 places over. So you get 80 cents. So 1% would be 80 cents. And $20 take away 80 cents. $19.20, which is your answer. In the second question, you have 38% of $120. So 40% is really 10% times 4. And for 10%, you can just move your decimal 1 place over. So 10% would be $12. So 40% would be $48. 1%, I would move my decimal over twice, so 1% would be $1.20, and 2% would be $2.40. So therefore, if you subtract that, you would get $45.60 as your answer. $45.60. In the seventh question, you have an algebra question that uses or requires distributive property. We've already learned that when you use distributive property, there are two ways to solve it. You can either expand it by multiplying both terms in the brackets by -10, or alternatively, you can divide both sides by the multiplier. I like this method better, so we'll use it. So instead of having -10 groups of x minus 6, I'm going to have one group of x minus 6 equals whatever this is. And 200 divided by -10 is -20. Once I get that, I'm going to add 6 to both sides. I'm going to x equals -14. Okay. In the eighth question, it says, what is the approximate value of the square root of 200? So we learned in chapter 3 that if you find the square root of 196 is 14, and the square root of 225 is 15, and it's just a little bit more than 14, so probably about 14.2, 14.1. If I double check with a calculator, I'm going to say 14.1 something. The square root of that is 14.14, so I better guess it would be 14.1. 14.2 is not wrong, because it says the approximate value. And the last question, number 9, is 3 3/8 divided by 4. What you want to do first is change mixed fractions to improper, change division to multiplication, and since 4 is really 4 over 1, if I'm changing it to multiplication, I need to use the reciprocal of the second fraction. The reciprocal of 4 is a quarter. Check for cross reduction, I can't, so multiply it out, you get 27 over 32, which is lowest terms.